Okay, so the last part of the chapter three review is 3.5. It's called slope-intercept form of a linear equation. I think everybody last year learned slope-intercept form. It's y is equal to mx plus b. So different than standard form where x and y were on the same side. Here, slope-intercept form is solved for y. Y is all by itself. And then m is the slope of the equation. That's rise over run. And then b is the y-intercept of the equation. So for example, something like y is equal to negative 3x minus 1. So in this case, negative 3 is the slope, and then negative 1 is the y-intercept. And if I wanted to graph that, you always actually have to start at the y-intercept. You don't start with the slope. The y-intercept, I said, is negative 1. That's a point on the graph. The slope is rise over run. So the slope, or m, is negative 3, or it's probably easier to write that as a fraction, negative 3 over 1, because I could use that to find other points on my graph. So from the y-intercept, rise actually is down 3 because the rise is negative, and then the run is 1, so that's to the right 1. You want to do both, down 3 and right 1. I don't want to just go down 3 and then make a point, and then right 1 and make a point, because then all the points wouldn't be in a line. So down 3, right 1. That's really good enough to be able to graph the line. But if you wanted to, you can continue that pattern. So from this point, I can go down 3, right 1 again. And then your line would go through each of those points. If you're given 2 points, so just taking a look at another example, say 2, negative 5, and 3, 7. And I wanted to calculate or find the slope of a line between those 2 points without graphing, I could use the equation or the formula for slope. So remember, m is a slope, and then the equation or formula, you should know this. If you don't have this written down, write it down somewhere, is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. It's the y's over the x's, because this is the rise. You rise either up or down. That's the y direction. And then this is the run. But to calculate the slope between these 2 points, I want to label each of the points. Instead of this just being x and y and this being x and y, like we need some way to be able to tell that x is apart and then the y is apart, because there's 2 of each. So we use these subscripts. So your first point, you could always label that x sub 1. That's technically x subscript 1. We just abbreviate y sub 1. And then x sub 2, y sub 2. If you label everything, it should be a lot easier to plug things into the equation for slope. So y sub 2, 7, minus y sub 1, so minus negative 5. Subtracting a negative is the same as adding a positive, so 7 plus 5 over 3, that's x sub 2, minus x sub 1. 7 plus 5, 12, over 3 minus, I thought I said 2, but I wrote 1. So 3 minus 2 is 1. 12 over 1, and I actually just want to leave it like that. 12 over 1 instead of just 12, because if I wanted to graph, it's going to be easier as a fraction. And then speaking of fractions, for slope, if it were something like 2/3, leave it as 2/3. Don't write it as 0.67 or 0.7 or even 0.6 repeating, because that's going to be a lot harder to graph. So you always want to leave your slope as a fraction, but you always want to leave the fraction as a simplified fraction. So for example, if you have something like 4/6, then you definitely need to simplify that to 2/3. That's slope and slope-intercept form.